Chapter 4. Rational Numbers. In the previous class, we have learnt about natural numbers, whole numbers and integers. We also learnt about fractions and concept of addition, subtraction, multiplication and division on them. In this chapter, we shall extend the number system and learn about rational numbers. Let us first recall what we have learnt earlier. Natural numbers. The counting numbers 1, 2, 3, 4, 5, etc. are called natural numbers. Whole numbers. All natural numbers including 0 are called whole numbers. Thus, 0, 1, 2, 3, 4, 5, etc. are all whole numbers. Integers. All whole numbers, along with negatives of natural numbers, are known as integers. Thus, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, etc. are all integers. Fractions. The numbers in the form a upon b, where a and b are whole numbers and b not equal to 0 are called fractions. Thus, 1 upon 3, 3 upon 5, 7 upon 9, etc. are all fractions. Rational numbers. In the adjoining figure, a circle is divided into 3 equal parts. Each part is equal to 1 upon 3. 2 parts out of 3 are shaded. That is, 2 upon 3 parts is shaded. The fraction 2 upon 3 denotes that a number 2 is divided by 3, but 2 is not divided by 3. The numerator is not divisible by the denominator completely, and such numbers do not resemble any number system studied earlier. Such numbers are called rational numbers. So, all fractions are rational numbers. A number that can be expressed in the form p upon q, where p and q are integers and q not equal to 0 is called a rational number. 2 upon 3, -3 upon 5, -4 upon 7, 0, 1 upon 2, etc. are all rational numbers. Examples of rational numbers. 0 is a rational number since 0 can be written in the form p upon q, where p equal to 0 and q not equal to 0. 0 is equal to 0 upon 1 equal to 0 upon -1 equal to 0 upon 2 equal to 0 upon -2 equal to 0 upon 3 equal to 0 upon -3 and so on. This implies 0 is equal to 0 upon q, where q is an integer and q not equal to 0. Every natural number is a rational number, but a rational number may not be a natural number. We know that 1, 2, 3, 4, 5, 6, etc. are natural numbers. They can be written as 1 upon 1, 2 upon 1, 3 upon 1, 4 upon 1, and so on. Thus, every natural number is a rational number. Let us take numbers 2 upon 3, 3 upon 5, 7 upon 5, 9 upon 11, etc. These are rational numbers, but they are not natural numbers. Hence, every natural number is a rational number, but a rational number is not necessarily a natural number. Every fraction is a rational number, but a rational number need not be a fraction. Let a upon b be any fraction, where a and b are whole numbers, where b not equal to 0. Every whole number is an integer. Therefore, a and b are integers. Thus, a upon b is a rational number. Consider a rational number 2 upon -3, where 2 is a whole number but -3 is not a whole number. Therefore, 2 upon -3 is not a fraction. Every integer is a rational number, but a rational number need not be an integer. We know that 2 is equal to 2 upon 1, -2 is equal to -2 upon 1, 3 is equal to 3 upon 1, -3 is equal to -3 upon 1, and so on. Any integer p can be written as p upon 1, which is a rational number. Now, consider the numbers 2 upon 3, 5 upon 2, -7 upon 4, 9 upon 7, etc. These are rational numbers, but these are not integers. Positive rational numbers. A rational number is said to be positive if its numerator and denominator are either both positive or both negative. For example, 3 upon 5 minus 12 upon minus 7, 13 upon 9, minus 41 upon minus 39, 23 upon 27 are positive rational numbers. Negative rational numbers. A rational number is said to be negative if its numerator and denominator have opposite signs. For example, minus 2 upon 3, 4 upon minus 7, minus 9 upon 5, 11 upon minus 7, minus 13 upon 5 are negative rational numbers.
Absolute value of a rational number. If P divided by Q is a rational number, then absolute value of P divided by Q is written as mod of P divided by Q is equal to mod of P divided by mod of Q. Examples: 1. Mod of 4 divided by 9 is equal to mod of 4 divided by mod of 9 is equal to 4 divided by 9. 2. Mod of minus 7 divided by 6 is equal to mod of minus 7 divided by mod of 6 is equal to 7 divided by 6. 3. Mod of minus 11 divided by minus 9 is equal to mod of minus 11 divided by mod of minus 9 is equal to 11 divided by 9.
Properties of rational numbers. If P upon Q is a rational number and M is any non-zero integer, then P upon Q is equal to P into M upon Q into M. In other words, a rational number remains unchanged if its numerator and denominator are multiplied by the same non-zero number. Examples: minus 7 upon 9 is equal to minus 7 into 3 upon 9 into 3, which is equal to minus 21 upon 27. M is equal to 3. 3 upon minus 5 is equal to 3 into 2 upon minus 5 into 2, which is equal to 6 upon minus 10. M is equal to 2. Minus 4 upon minus 3 is equal to minus 4 into minus 1 upon minus 3 into minus 1, which is equal to 4 upon 3. M is equal to minus 1. If P upon Q is a rational number and R is a common divisor of P and Q, then P upon Q is equal to P divided by R upon Q divided by R. In other words, if we divide the numerator and denominator of a rational number by a common divisor of both, then the rational numbers remain unchanged. Examples: minus 15 upon 10 is equal to minus 15 divided by 5 upon 10 divided by 5 is equal to minus 3 upon 2. R is equal to 5. 12 upon minus 24 is equal to 12 divided by 12 upon minus 24 divided by 12 is equal to 1 upon minus 2. Minus 12 upon minus 15 is equal to minus 12 divided by minus 3 upon minus 15 divided by minus 3, which is equal to 4 upon 5. R is equal to rational numbers. Two rational numbers are said to be equivalent if one of the rational numbers can be obtained from the other by multiplying or dividing numerator and denominator by the same non-zero number. Let us take few more examples to understand the above concept. Example 1. Write each of the following rational numbers with positive denominator. 3 upon minus 7, minus 12 upon minus 7. Solution: 3 upon minus 7 is equal to 3 into minus 1 upon minus 7 into minus 1, which is equal to minus 3 upon 7. Minus 12 upon minus 7 is equal to minus 12 into minus 1 upon minus 7 into minus 1, which is equal to 12 upon 7. Standard form of a rational number. Consider the rational numbers 2 upon 3, minus 3 upon 7, 5 upon 8, minus 8 upon 11. The denominators of these rational numbers are positive integers, and 1 is the only common factor between the numerators and denominators. Such rational numbers are said to be in standard form. A rational number is said to be in the standard form if its denominator is a positive integer and the numerator and denominator have no common factor other than 1. To reduce the rational number to its standard form, we divide its numerator and denominator by their HCF. If there is negative sign in the denominator, we make the denominator positive by multiplying the numerator and denominator by -1. Example 1. Express each of the following rational numbers in standard form: -12 upon 54, 22 upon -55. Solution. The given rational number is -12 upon 54. The HCF of 12 and 54 is 6. -12 upon 54 is equal to -12 divided by 6 upon 54 divided by 6, which is equal to -2 upon 9. Therefore, -12 upon 54 in standard form can be written as -2 upon 9. The given rational number is 22 upon -55. The HCF of 22 and 55 is 11. 22 upon -55 is equal to 22 divided by 11 upon -55 divided by 11, which is equal to 2 upon -5. Now, 2 upon -5 is equal to 2 into -1 upon -5 into -1, which is equal to -2 upon 5, multiplying by -1 to make the denominator positive. Hence, 22 upon -55 in its standard form is equal to -2 upon 5. Example 2. Write the rational number 87 upon -116 in standard form. Solution. The given rational number is 87 upon -116. The HCF of 87 and 116 is 29. 87 upon -116 is equal to 87 divided by -29 upon -116 divided by -29 is equal to -3 upon 4. Dividing by negative of HCF to make the denominator positive. Hence, 87 upon -116 in its standard form is equal to -3 upon 4. Representation of rational numbers on the number line. We have learnt in previous class that integers can be represented on the number line by taking 0 at the center on any line. Equal distances on the right as well as on the left of 0 are marked. Such a distance is known as a unit length. The points A, B, C, D, E, F represent the positive integers 1, 2, 3, 4, 5, 6, and the points A dash, B dash, C dash, D dash, E dash, F dash represent the negative integers -1, -2, -3, -4, -5, -6 respectively on the above number line. Rational numbers can also be represented on the number line. Since OA is equal to +1 unit, the midpoint of OA represents half or 1 upon 2. Similarly, midpoint of OA dash represents -1 upon 2. Example 1. Represent 3 upon 4 on the number line. Solution. Draw a line and take a point O on it to represent 0. Take a point A such that OA is equal to +1 unit. Divide OA into 4 equal parts. Each part represents 1 upon 4. Point B represents 3 upon 4 on the number line. Example 2. Represent 7 upon 3 and -7 upon 3 on the number line. Solution. We draw a line and mark a point O at the center on it to represent 0. We mark 3 points A, B and C at equal distances on the right of 0 and 3 points A dash, B dash and C dash at equal distances on the left of O respectively. 7 upon 3 is equal to 2 and 1 upon 3 will be between 2 and 3. We divide BC into 3 equal parts, each part representing 1 upon 3. Point B represents 7 upon 3 on the number line. Similarly, divide B dash, C dash into 3 equal parts. Minus 7 upon 3 will be between minus 2 and minus 3. Similarly, minus 7 upon 3 is equal to minus 2 and 1 upon 3. Point Q represents minus 7 upon 3 on the number line. Comparison of rational numbers. We have already learnt how to compare two integers and also two fractions. Now, we have the following facts about the comparison of rational numbers. Every positive rational number is greater than every negative rational number. 0 is greater than every negative rational number and is less than every positive rational number. Every rational number represented by a point on the number line is greater than every rational number represented by points on its left and less than every rational number represented by points on its right. Left, 0, right. How to compare rational numbers? If two integers are not equal, one will be smaller and other will be greater. Similarly, two fractions or rational numbers can be compared. If they are not equal, we can use the following steps to compare rational numbers. Step 1. Express each of the given rational numbers with positive denominator. Step 2. Find out the LCM of these denominators. Step 3. Express each rational number with this LCM as the common denominator. Step 4. The number having the greater numerator will be greater. Let us take few examples and compare rational numbers. Example 1. Which of the rational numbers is greater? Minus 6 upon 11, 5 upon minus 8. Solution. Minus 6 upon 11 is equal to minus 6 upon 11. 5 upon minus 8 is equal to 5 into minus 1 upon minus 8 into minus 1, which is equal to minus 5 upon 8, making denominator positive. LCM of denominators 11 and 8 is 88. Minus 6 upon 11 is equal to minus 6 into 8, which is equal to 11 into 8, which is equal to minus 48 upon 88. And minus 5 upon 8 is equal to minus 5 into 11 upon 8 into 11, which is equal to minus 55 upon 88. Since denominators are same and minus 48 greater than minus 55, therefore, minus 48 upon 88 greater than minus 55 upon 88. This implies minus 6 upon 11 greater than minus 5 upon 8. Example 2. Arrange the following rational numbers in descending order. 4 upon 21, minus 6 upon 7, 23 upon 35, 9 upon minus 14. Solution. Rational numbers are 4 upon 21, minus 6 upon 7, 23 upon 35 and 9 upon minus 14. This implies numbers are 4 upon 21, minus 6 upon 7, 23 upon 35, minus 9 upon 14. LCM of denominators 21, 7, 35, 14 is equal to 7 into 3 into 5 into 2, which is equal to 210. This implies 40 upon 210 minus 180 upon 210, 138 upon 210 minus 135 upon 210, making denominators equal. This implies 138 upon 210, 40 upon 210 minus 135 upon 210 minus 180 upon 210, arranging in descending order. Therefore, 23 upon 35, 4 upon 21, 9 upon minus 14, minus 6 upon 7 are in descending order. Rational numbers between two rational numbers. Let us count the whole numbers between 2 and 9. There are exactly 6 whole numbers between 2 and 9 vis-a-vis 3, 4, 5, 6, 7 and 8. Similarly, total number of integers between minus 2 and 2 are exactly 3 vis-a-vis minus 1, 0 and 1. Thus, we find that total number of whole numbers between two whole numbers are finite, limited, and total number of integers between two integers are also finite. Will happen in case of rational numbers also. Let us now consider two rational numbers minus 2 upon 3 and 1 upon 2. Equivalent forms of minus 2 upon 3 and 1 upon 2 are minus 2 upon 3 equal to minus 2 into 2 upon 3 into 2, which is equal to minus 4 upon 6. 1 upon 2 is equal to 1 into 3 upon 2 into 3, which is equal to 3 upon 6. Now, minus 4 upon 6 less than 3 upon 6. Also, minus 4 upon 6 less than minus 3 upon 6 less than minus 2 upon 6 less than minus 1 upon 6 less than 0 less than 1 upon 6 less than 2 upon 6 less than 3 upon 6 are the numbers minus 3 upon 6, minus 2 upon 6, minus 1 upon 6, 0, 1 upon 6, 2 upon 6. The only rational numbers between minus 4 upon 6 and 3 upon 6. We can also write minus 2 upon 3 is equal to minus 2 into 4 upon 3 into 4 is equal to minus 8 upon 12 and 1 upon 2 is equal to 1 into 6 upon 2 into 6 is equal to 6 upon 12. Clearly, minus 8 upon 12 less than 6 upon 12. Also, minus 8 upon 12 less than minus 7 upon 12 less than minus 6 upon 12 less than minus 5 upon 12 and so on, less than 3 upon 12 less than 4 upon 12 less than 5 upon 12 less than 6 upon 12. Thus, there are infinite rational numbers between any two rational numbers. Examples: list 3 rational numbers between minus 4 upon 5 and minus 2 upon 3. Solution: we have minus 4 upon 5 and minus 2 upon 3. Let us write these rational numbers with denominator 30. Minus 4 upon 5 is equal to minus 4 into 6 upon 5 into 6 equal to minus 24 upon 30, and minus 2 upon 3 is equal to minus 2 into 10 upon 3 into 10, which is equal to minus 20 upon 30. Clearly, minus 24 upon 30 less than minus 20 upon 30. So, minus 24 upon 30 less than minus 23 upon 30 less than minus 22 upon 30 less than minus 21 upon 30 less than minus 20 upon 30. This implies minus 4 upon 5 less than minus 23 upon 30 less than minus 11 upon 15 less than minus 7 upon 10 less than minus 2 upon 3. Hence, the three rational numbers between minus 4 upon 5 and minus 2 upon 3 are minus 23 upon 30, minus 11 upon 15 and minus 7 upon 10.